Hello everyone. Today we will study linear inequality. First of all, let me introduce some inequality symbols. This symbol here is called greater than. This symbol is called greater than or equal to. This symbol is called less than. This symbol is called less than or equal to. This symbol is called not equal to. In general, an inequality is an algebraic expression which involves inequality symbol or symbols. In an inequality, it may contain multiple symbols, multiple inequality symbols. Note, in general, an inequality can be expressed using a graph, or it could be written using interval notation. What is the graph of interval? And what is interval notation? Next, let me show you some examples. First of all, let's look at this inequality. X is greater than 2. How does the graph look like? In order to graph inequality, let's draw a number line first. In the number line, we have 0 in the middle. Numbers from the right side are positive. Numbers from the left side are negative. For the numbers on the right side, from 1, 2, 3, 4, 5, it goes all the way to infinity. This symbol represents infinity. And for the numbers on the left side, from -1, -2, -3, -4, it goes all the way to negative infinity. Number on the left side go all the way to negative infinity. Now, for this inequality, x is greater than 2. Number 2 is not included. If number 2 is not included, we draw empty circle at 2. If number 2 is not included, we draw empty circle at 2. If 2 is included, then we draw a solid circle at 2. If 2 is included, we draw a solid circle at 2. Here, since number 2 is not included, we draw empty circle at 2. This empty circle is also called open circle. So if number 2 is not included, we draw open circle at 2. Next, how do we graph x is greater than 2? We know that numbers to the right side of 2 are greater than 2. Numbers to the right side, we have 3, 4, 5. They are all greater than 2. So we straight the region to the right side of 2 on the number line. Straight the region to the right side of 2. So that's the graph of this inequality. That's the graph of this inequality. Next, let me show you the interval notation for this inequality. How do we write this inequality in interval notation? For interval notation, look at the graph. In the graph, the shaded region is from 2 to infinity. In the graph, the shaded region is from 2 to infinity. In this region, the left endpoint is 2. The right endpoint is infinity. So that's the interval notation for this inequality. That's the interval notation for this inequality. This interval notation, in general, it means all real numbers from 2 to infinity, not including 2. Parentheses means number 2 is not included. If 2 is included, we use bracket. Bracket means included. Parentheses means not included. So this interval notation represents all real numbers from 2 to infinity, not including 2. All real numbers from 2 to infinity, not including 2. Next example. x is greater than or equal to -1. How do we graph this inequality? So first of all, natural number line. Number lines from -infinity to infinity. We know that -1 is somewhere on the number line. -1 is somewhere on the number line. In this inequality, x is greater than or equal to -1, so -1 is included. If -1 is included, we draw a solid circle at -1. We know that -1 is somewhere on the number line. And let's make it simple. Put -1 here. Since -1 is included, we draw a solid circle at -1. Now, we try to graph x is greater than or equal to -1. We know that numbers to the right side of -1 are greater than -1. In general, numbers to the right side are larger. Numbers to the left side are smaller. So we show the region to the right side of -1. Since -1 is included, we use a solid circle to represent -1 is included. This solid circle is also called a closed circle. That's the graph of this inequality. Next, let's try to run this inequality using interval notation. Let's try to run the inequality using interval notation. Look at the graph here. The left endpoint for the shaded region, the left endpoint is -1. Right endpoint is infinity. Since -1 is included, we use angle bracket. Angle bracket means -1 is included. That's left endpoint. Right endpoint is infinity. For interval notation, we never include infinity or negative infinity. For interval notation, we never include infinity or negative infinity because they are non-real numbers. So here we include -1 because -1 is included. If -1 is included, use angle bracket. That means -1 is included. This symbol represents all real numbers from -1 to infinity. Including -1. Parenthesis means endpoint is not included. Angle bracket means endpoint is included. So that's an interval notation for this inequality. Next example. X is less than 3. How do we graph this inequality? First of all, let's draw a number line. Number 3 is somewhere on the number line. Make it simple. Number 3 is somewhere on the number line. Since number 3 is not included, draw open circle as 3. Since number 3 is not included, draw open circle as 3. We know that number line varies from infinity to infinity. We try to graph a region that x is less than 3. We know that numbers to the right side are greater than 3. Number to the left side will be less than 3. Number to the right side is greater than 3. Number to the left side is less than 3. So we show a region to the left side of number 3. Show the region to the left side of number 3. That's the graph of this inequality. That's the graph of this inequality. Next, let's try to run the inequality using interval notation. For the shaded region here, we can see that left endpoint is negative infinity. Right endpoint is number 3, not including 3. So for the interval notation, we write negative infinity and 3. For the shaded region here, left endpoint is negative infinity, and right endpoint is number 3. So this interval notation represents all real numbers. From negative infinity to 3. All real numbers from negative infinity to 3, not including 3. Parentheses means 3 is not included. So that's how we write this inequality in interval notation. Next example. X is less than or equal to negative 2. X is less than or equal to negative 2. How do we graph this inequality? Let's first of all draw a number line. Number line is always from negative infinity to infinity. Number line is always from negative infinity to infinity. X is less than or equal to negative 2. That means negative 2 is included. So draw a solid circle at negative 2. We know that negative 2 is somewhere on the number line. Negative 2 is somewhere on the number line. Since negative 2 is included, we draw a solid circle at negative 2. Next, we try to show the region for x is less than negative 2. We know that numbers to the left side are less than negative 2. Numbers to the right side are larger. Numbers to the left side are smaller. So show the region to the left side of negative 2. That's the graph for this inequality. Next, let's rewrite this inequality in interval notation. Let's rewrite this inequality using interval notation. For the shaded region here, the left endpoint is negative infinity, right endpoint is negative 2, and negative 2 is included. So the interval notation here is from negative infinity to negative 2. Negative 2 is included, so use angle bracket. Angle bracket means endpoint is included. Parentheses means endpoint is not included. We never include infinity or negative infinity. In interval notation, we never include infinity or negative infinity because they are non-real numbers. So this notation represents all real numbers. From negative infinity to negative 2, including negative 2. Angle bracket means endpoint is included. Next example, x not equal to 1. How do we graph this inequality? X not equal to 1. Let's draw a number line first. Number line is always from negative infinity to infinity. X is not equal to 1 means x could be any real number except 1. X not equal to 1 means x could be any real number except 1. So we draw open circle at 1. Since 1 is not included, draw open circle at 1. X could be any real number except 1. So shake everything on the number line except number 1. Shake everything on the number line except number 1. That means x could be any real number except 1. S not equal to 1 means s could be any real number except 1. That's the graph for this inequality. The entire line is straighted except number 1. The entire line is straighted except number 1. That's a graph for this inequality. Next, let's run this inequality using interval notation. How is the interval notation for this inequality looks like? In a graph here, we have 2 pieces. For a line, if I cut it in the middle, I get 2 pieces. For a line, if I cut it in the middle, I get 2 pieces. First piece is from negative infinity to 1. First piece is from negative infinity to 1. Second piece is from 1 to infinity. 1 is not included. If I cut a line in the middle, I get 2 pieces. First piece is from negative infinity to 1. Second piece is from 1 to infinity. Now, if there are multiple intervals, we use a symbol called union to connect 2 intervals. This symbol here is called union. If there are multiple intervals, we use union to connect intervals. If there are multiple intervals, we use union to connect 2 intervals. So that's the interval notation for this inequality, x not equal to 1. That's the interval notation for this inequality. Next, how about this inequality? X is from 1 to 5. Not including 1, not including 5. How is the graph looks like? Let's draw a number line first. Number 1 is somewhere on the number line. Since it's not included, draw open circle for number 1. Number 1 is somewhere on the number line. Since it's not included, draw open circle for number 1. Number 5 is also somewhere on the number line. And 4 is greater than 1. So we know 4 is on the right side of 1. Since 4 is greater than 1, so we know number 4 is on the right side of 1. So draw open circle for both number 1 and number 5, because they are not included. Now, x is between 1 and 5, so we straight all regions, straight the region between 1 and 5. X is between 1 and 5, so we straight the region between 1 and 5. Straight the region between 1 and 5. That's the graph for this inequality. Now, how do we write this inequality using interval notation? For the shaded region here, the left endpoint is 1, right endpoint is 5, and they are not included. We use parentheses. If they are not included, we use parentheses. From 1, all real numbers from 1 to 5. This interval notation means all real numbers from 1 to 5, not including 1 and 5. All real numbers from 1 to 5, not including 1 and 5. Parentheses means endpoints are not included. Next example. X is between -1 and 3. -1 and 3, they are both included. How is the graph looks like? Let's draw a number line first. Number line is always from -infinity to infinity. -1 is somewhere on the line, and it's included. number 3 is larger than -1. It's somewhere on the number line. And 3 is also included. Draw a solid circle if it's included. We are looking for real numbers between -1 and 3. We are looking for numbers between -1 and 3. So shade the region between -1 and 3. That's a graph for this inequality. How do we write the inequality in interval notation? For the shaded region here, left endpoint is -1, right endpoint is number 3. So write the interval from -1 to 3, including both -1 and 3. This notation means all real numbers from -1 to 3. All real numbers from -1 to 3. Including both -1 and 3. That's the interval notation for this inequality. Next example. X is between 4 and A, including A, but not 4. X is between 4 and A, including A, but not 4. How does the graph look like? Let's draw a number line first. Number line is always from -infinity to infinity. Number 4 is somewhere on the number line. And since number 4 is not included, we draw open circle. Since number 4 is not included, draw open circle. Number 8 is greater than 4. It's somewhere to the right side of 4. Since number 8 is included, draw a solid circle at number 8. Then X is between 4 and A, so shade all region, shade the region between 4 and A. That's a graph for this inequality. Then next, for the interval notation, look at the shaded region. It's from 4 to A, not including 4, but including A. Parentheses means 4 is not included. Angle bracket means A is included. So this notation represents all real numbers from 4 to A. Including A, but not 4. All real numbers from 4 to A, including A, but not 4. Next example. How do we graph the inequality? X is between -5 and -2, including -5, but not -2. How does the graph looks like? Let's draw a number line first. Number line is always from -infinity to infinity. -5 is somewhere on the line, and since -5 is included, draw a solid circle for -5. and negative 2 is not included. Draw open circle and negative 2. X is between negative 4 and negative 2. So straighten the region between negative 4 and negative 2. Since X is between negative 4 and negative 2, we straighten the region between negative 4 and negative 2. That's a graph of this inequality. Next, let's write the inequality using interval notation. Let's write the inequality using interval notation. Look at the graph. The straightened region is from negative 5 to negative 2, including negative 5, not including negative 2. Angle bracket means negative 5 is included. Parenthesis means negative 2 is not included. So this interval represents all real numbers from negative 5 to negative 2, including negative 5, but not negative 2. Including negative 5, but not negative 2. That's the interval notation for this inequality. In example 6, if both endpoints are not included, that's called open interval. If both endpoints are not included, this is called open interval. If both endpoints are not included, it's called open interval. In example 7, if both endpoints are included, that's called closed interval. If both endpoints are included, that's called closed interval. In example 8 and 9, if one endpoint is included, the other one is not included, that's called half open interval. If one endpoint is not included, the other one is not included. One endpoint is included, the other one is not included, that's called a half open interval. If one endpoint is included, the other one is not included, that's called a half open interval. Same thing for number 9. If one endpoint is included, the other one is not included, that's called a half open interval. Next, let's do some computation about inequalities. Solve each of the following inequalities. Graph the solution and write the answer in interval notation. First example, x plus 5 is less than 12. The way to solve inequality is very similar as solving equations. We try to get x by itself on the left side. So here I can subtract 5 from both sides. On the left side, I get x by itself. On the right side, 12 minus 5 is 7. So the solution is x less than 7. Now next, let's graph x less than 7. Number line is always from net infinity to infinity. Number 7 is somewhere on the line. Since 7 is not included, draw open circle for 7. For x less than 7, straighten the region to the left of 7. That's a graph. For interval notation, look at the graph here. Left endpoint is net infinity. Right endpoint is number 7. 7 is not included. Draw open circle. So that's an answer. Next, x minus 7 is greater than -9. So the way to solve inequality is very, very similar as solving equations. We try to get x by itself on the left side. So here, I can add 7 to both sides. On the left side, 7 can cancel, we get x by itself. On the right side, -9 plus 7. When we're adding two numbers with different sign, take the sign from a number that has larger magnitude. Here, number 9 is larger. Take negative sign. Then subtract the magnitude. 9 minus 7 is 2. So the solution is x is greater than -2. Solution is x is greater than -2. Draw number line. Number line is always from net infinity to infinity. -2 is somewhere on the line. Since it's not included, draw open circle. X is greater than -2. You know the number to the right side is greater. So to the region to the right side of -2. That's a graph for the solution. For interval notation, look at the graph here. Left endpoint is -2, which is not included. Right endpoint is infinity. So the interval is from -2 to infinity, not including -2. From -2 to infinity, not including -2. That's an answer. Next, 3x plus 1 is less or equal to -14. 3x plus 1 is less or equal to -14. So the way to solve inequality is very, very similar as solving equations. Try to get x by itself. I can first of all subtract 1 from both sides. On the left side, positive 1, negative 1 can cancel. You get 3x by itself. On the right side, -14 plus -1, what do we get? When we're adding two numbers with the same sign, keep the sign and the magnitude. 14 plus 1 is 15. Then, in order to get x by itself, I can divide both sides by 3. On the left side, number 3 can cancel, we get x by itself. On the right side, -15 divided by 3 is -5. Here, x is less or equal to -5. That's the answer. Now, sketch the graph. Draw number line first. -5 is somewhere on the number line. Since -5 is included, draw a solid circle for -5. X is less than or equal to -5. So show the region to the left side of -5. Left side means smaller. Number on the left side is smaller. Number on the right side is larger. Since x is less than -5, show the region to the left side of -5. That's a graph for the answer. Now for interval notation, look at the graph here. The left endpoint is net infinity. Right endpoint is -5. So from net infinity to -5, including -5. From net infinity to -5, including -5. That's an answer for this problem. Next, 2x minus 5 is greater or equal to 9. So to get x by itself, first of all, I can add 5 to both sides. On the left side, I get 2x. On the right side, 9 plus 5 is 14. Then I can divide both sides by 2. I get x is greater than or equal to 7. That's the solution. Next, let's graph the solution. Draw number line first. Number 7 is somewhere on the line. Since 7 is included, draw a solid circle at 7. X is greater than 7, so show the region to the right side of 7. That's a graph for this inequality. Next, let's write the answer in interval notation. Look at the region here. Left endpoint is number 7. Since number 7 is included, we use angle bracket. Right endpoint is infinity. Right endpoint is infinity. Infinity is always not included. We never include infinity as an answer. Infinity is always not included. Infinity is always included. It's always not included. We can never include infinity in interval notation. Next, 7 plus 4x is not equal to negative 13. 7 plus 4x is not equal to negative 13. So I can first of all subtract 7 from both sides. On the left side, positive 7 and negative 7 can cancel to get 4x by itself. On the right side, negative 13 plus negative 7. When we're adding two numbers of the same sign, keep the sign and the magnitude. 13 plus 7 is 20. Then I can divide both sides by 4. On the left side, I get x. On the right side, negative 20 divided by 4 is negative 5. Now, how do we graph x not equal to negative 5? Let's draw number line first. X not equal to negative 5 means x could be any real number except negative 5. So, since x cannot be negative 5, means negative 5 is not included. Let's draw open circle for negative 5. And since x can be any real number except negative 5, we shade the entire line except negative 5. Shade the entire line except negative 5. That's the graph to the solution. Now, for interval notation, if I cut a line in the middle, I get 2 pieces. If I cut a line in the middle, I get 2 pieces. First piece is from negative infinity to negative 5, not including negative 5. Second piece is from negative 5 to infinity, not including negative 5. And then if there are 2 intervals, we use interval with union to connect 2 intervals. If there are 2 intervals, we use union in the middle to connect 2 intervals. That's an answer to this problem. Next, 7x plus 3 not equal to negative 20. 7x plus 3 not equal to negative 20. So here, I can first of all subtract 3 from both sides. On the left side, positive negative 3 can cancel, we get 7x by itself. On the right side, negative 20 and negative 3. When we're adding 2 numbers of the same sign, keep the sign and the magnitude. 20 plus 3 is 23. And then I can divide both sides by 7. On the left side, I get x by itself. 7 can cancel. On the right side, 23 and 7 is not divisible, so we leave it the way it is. 23 and 7 is not divisible, we leave it the way it is. That's the solution to this inequality. Next, let's graph an answer. Negative 27 over 3 is somewhere on the number line. Negative 23 over 7 is somewhere in the middle of number line. S can be any real number except negative 23 over 7. So we can shade the entire line except this number. Shade the entire line except this number. That's the graph for the solution. Next, we try to write an answer using interval notation. For interval notation, if I cut a line in the middle, I get 2 pieces. First piece is from negative infinity to negative 23 over 7, not including 23 over 7. Second piece is from negative 23 over 7 to infinity, not including negative 23 over 7. If there are 2 intervals, we use union in the middle to connect two intervals. If there are two intervals, use union in the middle to connect two intervals. That's the interval notation for the solution. Next, negative 3x is less than 15. Negative 3x is less than 15. In order to get x by itself, I divide both sides by negative 3. In order to get x by itself, I divide both sides by negative 3. Now, for inequality, be very, very careful. For inequality, be very, very careful. When we divide inequality by negative number, always switch the direction for inequality. When we multiply or divide inequality by negative numbers, always switch the direction for inequality sign. So on the left side, we get x by itself. On the right side, 15 divided by negative 3 is negative 5. So keep it in mind. When we multiply or divide inequality by negative numbers, always switch the direction. For example, let me show you an example. For example, we know that negative 4 is greater than negative a. Negative 4 is greater than negative a. For example, if I divide both sides by a negative number, what do we get? Negative 4 divided by negative 2 is positive 2. Negative 8 divided by negative 2 is positive 4. Here 4 is greater than 2. So when we multiply or divide inequality by negative numbers, always switch the direction. For example, another example. Negative 1 is greater than negative 7. If I multiply both sides by 2, for example, if I multiply both sides by negative 2, what do I get? On the left side, negative 1 times negative 2 is positive 2. On the right side, negative 7 times negative 2 is positive 14. You can clearly see that 14 is larger than 2. So 2 is less than 14. So for inequality, if I multiply or divide both sides by negative numbers, always switch the direction for inequality sign. When we multiply or divide inequality by negative numbers, always switch the direction for inequality sign. Here, since I divide both sides by negative 3, I switch the inequality sign. Let them become greater than. That's an answer. That's a solution to this inequality. Now, next, we try to graph an answer. How do we graph the solution? X is greater than negative 5. Negative 5 is somewhere on the number line. That's negative 5. Negative 5 is not included, so we draw open circle. X is greater than negative 5. We show the regions to the right side of negative 5. That's a graph to the solution. And then for interval notation, look at the graph here. Left endpoint is negative 5. Right endpoint is infinity. And negative 5 is not included. Use parentheses. Negative 5 is not included. Next example. Negative 4x is greater than or equal to negative 27. Negative 4x is greater than or equal to negative 27. So here, we can divide both sides by negative 4. If I divide inequality by negative numbers, always switch the direction of inequality sign. If I divide inequality by negative number, always switch the direction for inequality sign. On the left side, I get x by itself. On the right side, we know that double negative is positive, but 27 over 4, 27 divided by 4 is not divisible, so I leave it the way it is. 27 divided by 4 is not divisible, so I leave it the way it is. That's the answer, that's the solution for this inequality. Now, how about the graph? For the graph, let's draw a number line first. We know that 27 over 4 is somewhere in the number line. Since the number is included, I draw a solid circle for 27 over 4. Here, x is less than or equal to 27 over 4. So show the region to the left side of 27 over 4. For interval notation, look at the graph here. Left endpoint is negative infinity. Right endpoint is 27 over 4. Since 27 over 4 is included, draw angle bracket. Angle bracket means it's included. Endpoint is included. We never include infinities. We never ever include infinities. Next, 10 minus 7x is less or equal to negative 18. So here I can first of all subtract 10 from both sides. On the left side, I get negative 7x by itself. On the right side, negative 18 plus negative 10. When we're adding two numbers with the same sign, keep the sign and the magnitude. 18 plus 10 is 28. Next, I can divide both sides by negative 7. If I divide inequality by negative number, I need to switch the direction of inequality sign. So less than or equal to become greater than or equal to. On the left side, I get s by itself. On the right side, double negative is positive. 28 divided by 7 is 4. That's the solution to this inequality. Now next, the graph. First of all, draw a number line. Number 4 is somewhere in the number line, and 4 is included. S is greater than 4. Show the region to the right side of 4. Show the region to the right side of 4. For interval notation, look at the graph here. Left endpoint is 4. Right endpoint is infinity. Next, negative 5 minus x is greater than negative 1. So try to get s by itself. I can first of all add 5 to both sides. On the left side, positive 4 and negative 4 can cancel. We get negative x by itself. On the right side, negative 1 plus 5, what do we get? When we're adding two numbers with different signs, keep the sign from the number that has larger magnitude. Here, 5 has larger magnitude, so keep positive sign. Then subtract the magnitude. 5 minus 1 is 4. So here, negative x is greater than positive 4. How can I get x by itself? Here, think of negative x is negative 1 times x. For negative x, think of negative 1 times x. And then I can divide both sides by negative 1. If I divide both sides by negative 1, I get s by itself. On the right side, I get negative 4. 4 divided by negative 1 is negative 4. Now be very, very careful. If I divide inequality by negative number, I must switch the direction for inequality sign. If I divide inequality by negative number, I must switch the direction for inequality sign. That's the solution. Next, the graph. For the graph, draw number line first. Negative 4 is somewhere in the number line. And since negative 4 is not included, draw open circle. Number to the left side is less than negative 4. That's the graph. And for the answer, interval notation. Look at the graph here. Left endpoint is negative infinity. Right endpoint is negative 4. Negative 4 is not included. So that's an answer in interval notation. Next, 2x minus 5 is greater than 7x plus 10. The way to solve inequality is very, very similar as solving equation. We try to get x by itself on the left side. So if there are 2x, I try to group x to the left side. So subtract 7x from both sides first. On the right side, 7x can cancel. On the left side, 2x and negative 7x. When we're adding two numbers with different signs, keep the sign from the number that has larger magnitude, and then subtract the magnitude. 7 minus 2 is 5. I get negative 5x. Minus 5 stays the same, greater than 10. Next, I can add 5 to both sides. I get negative 5x is greater than 15. And then I can divide both sides by negative 5. Now be very, very careful. If I divide inequality by negative number, I have to switch the direction for inequality sign. If I divide inequality by negative number, I have to switch the direction for inequality sign. Here on the left side, I get x by itself. On the right side, 15 divided by negative 5 is negative 3. So the solution is x is less than negative 3. Now let's graph the answer. Negative 3 is somewhere in the number line. Since x is less than negative 3, show the region to the left side of the number line of negative 3. Show the region to the left side of negative 3. That's a graph. For the interval notation, look at the graph here. The left endpoint is negative a. The right endpoint is negative 3. And this negative 3 is not included. Use parentheses. That's the interval notation for the solution. Next, 6 minus 2x is greater than or equal to 5x minus a. 6 minus 2x is greater than or equal to 5x minus a. So if there are multiple x, if there are more than one x, we try to group x to the left side first. So here I can subtract 5x from both sides. On the right side here, 5x can cancel. On the left side, number 6 stays the same. Negative 2x and negative 5x. When we're adding two numbers of the same sign, keep the sign and the magnitude. 2 plus 5 is 7. X stays the same. On the right side, what's left is negative a. And then I can subtract 6 from both sides. On the left side, what's left is negative 7x. On the right side, negative a plus negative 6. When we're adding two numbers of the same sign, keep the sign and the magnitude. A plus 6 is 14. Next, I can divide both sides by negative 7. Here, be very, very careful. When we divide inequality by negative number, I have to switch the direction for the inequality sign. So greater than or equal to becomes less than or equal to. On the left side, I get x by itself. On the right side, negative 14 divided by negative 7. Double negative is positive. 14 divided by 7 is 2. So the solution is x less or equal to 2. Next, let's graph the solution. Draw number line first. Number 2 is somewhere in the number line. Since 2 is included, draw a solid circle. Here, x is less than or equal to 2. We know that the region to the left side is less than negative 2. Is less than 2. That's the graph for the solution. Next, for interval notation, look at the straight region here. The left endpoint is negative infinity. Right endpoint is 2. 2 is included. That's a solution. That's a solution in interval notation. Next, 4 times x minus 2 is less than 5x plus 3. The way to solve inequality is very similar as solving equations. If there are parentheses, let's distribute first. If I distribute, I get 4x minus a is less than 5x plus 3. Then if there are more than 1x, we try to group x to the left side. Here I can subtract 5x from both sides. If I subtract 5x from both sides, on the right side, 4x can cancel. On the left side, 4x minus 5x. When we're adding two numbers with different sign, keep the sign from the number that has larger magnitude. And then subtract the magnitude. 5 minus 4 is 1. Keep the sign from the number that has larger magnitude. And then subtract the magnitude. 5 minus 4 is 1. X stays the same. Minus 8 less than, on the right side what's left is number 3. Next, I can add 8 to both sides. If I add 8 to both sides, what's left on the left side is negative 1x less than 11. Next, I can divide both sides by negative 1. On the left side here, I can add by itself. On the right side, positive 11 divided by negative 1 is negative 11. For inequality, be very, very careful. If I divide inequality by negative number, I have to switch the direction of inequality sign. So less than become greater than. That's the solution to this inequality. Now let's graph the answer. Let's graph the solution. We know that negative 11 is somewhere in the number line, and it's not included. Draw open circle. Draw open circle is not included. X is greater than negative 11, which is the region to the right side of negative 11. That's the graph. And then for interval notation, look at the straight region here. Left endpoint is negative 11. Right endpoint is infinity. That's the solution in interval notation. Next, 7 minus 3x is less or equal to 2 times x plus 6. If there's parentheses, let's distribute first. I get 7 minus 3x is less than or equal to 12x plus 2x plus 12. Distribute 2 first. I get 2x plus 12. Then, if there are x on the left side and right side, we try to group x to the left side. Here I can subtract 2x from both sides. Then x on the right side can cancel. On the left side, number 7 stays the same. Negative 3x plus negative 2x. When we're adding two numbers with the same sign, keep the sign, add the magnitude. 3 plus 2 is 5. And then on the right side what's left is number 12. Next, I can subtract 7 from both sides. I get negative x is less or equal to 5. And then I can divide both sides by negative 5. On the left side, what's left is x. On the right side, positive 5 divided by negative 5 is negative 1. And be very, very careful. When we divide inequality by negative number, always switch the direction of inequality sign. Less than or equal to become greater than or equal to. That's the solution. That's the solution. Next, let's graph the solution. Negative 1 is somewhere in the number line, and negative 1 is included, so draw a solid circle. X is greater than or equal to negative 1. We know that the region to the right side here is greater than negative 1. So show the region to the right side. That's a graph for the solution. And next, for interval notation, look at the straight region here. For the straight region, the left endpoint is negative 1, and it's included. Right endpoint is infinity. Next, three times x minus 6 plus 5 is greater than or equal to 3 minus 4x. If there are parentheses, let's distribute first. If I distribute 3, I get 3x minus 18 plus 5 is greater or equal to 3 minus 4x. Next, I can combine like terms. Negative 18 plus 5, what do we get? When we're adding two numbers with different signs, keep the sign from the number that has larger magnitude, and then subtract the magnitudes. 18 minus 5 is 13. Right side stays the same. Next, we try to group x to the left side. Here I can add 4x to both sides. 3x plus 4x is 7x. Negative 13 stays the same. On the right side, what's left is number 3. Next, I can add 13 to both sides. I get 7x on the left side. On the right side, I got 16. And then divide both sides by 7. On the left side, I get x by itself. On the right side, 16 divided by 7, that's not divisible. So I leave it the way it is. That's the solution for this inequality. Next, let's graph the answer. Let's graph the solution. Draw number line first. 16 over 7 is somewhere in the number line, and it's included. We draw a solid circle. Since x is greater than or equal to x is greater or equal to 16 over 7, straight the region to the right side of 16 over 7. That's a graph. And then for the answer in interval notation, look at the straight region here. For the straight region, the left endpoint is 16 over 7. The right endpoint is infinity. Here, 16 over 7 is included, so use angle bracket. Next, 9 minus 2 times x minus 4 is greater than 2x minus 3. If there's parentheses, distribute first. Don't do 9 minus 2. That's a very, very common mistake. If there's a parentheses, distribute negative 2 first. Keep number 9 the way it is. Don't do 9 minus 2 here. Be very, very careful. Keep number 9 the way it is. Distribute negative 2 first. In an equation of inequality, if there's a parentheses, we must always distribute first. Distribute negative 2. I get negative 2x plus a is greater than 2x minus 3. And then try to combine like terms. If possible, combine like terms first. Here I can combine 9 and a. 9 plus a is 17. 9 plus a is 17. Leave the right side the same. Next, if you have x on the left side and right side, we try to group x to the left side. Subtract 2x. If I subtract 2x from both sides, on the right side 2x get cancelled. On the left side, negative 2x plus negative 2x. When we are adding two numbers with the same sign, keep the sign, add the magnitude. 2 plus 2 is 4. I get negative 4x plus 17 is greater than, on the right side, what's left is negative 3. Next, I can subtract 17 from both sides. What's left is negative 4x. 17 can cancel. Negative 3 plus negative 17. When we're adding two numbers with the same sign, keep the sign, add the magnitude. 3 plus 17 is 20. And then I can divide both sides by negative 4. If I divide inequality by negative number, we must switch the direction for inequality sign. So greater than become less than. On the left side, negative 4 can cancel, we get x by itself. On the right side, negative 20 over negative 4 is positive 5. Double negative is positive. And then let's graph the answer. Number 5 is somewhere in the number line. And number 5 is not included. Draw open circle. Here x is less than 5. Straight region to the left side of 5. Since x is less than 5, straight region to the left side of 5. And then for the answer in interval notation, look at the straight region here. For the straight region, left endpoint is negative infinity. Right endpoint is number 5. And number 5 is not included. That's an answer in interval notation. That's the answer in interval notation. Next, 4 is less than x plus 2 and less than 10. This is an inequality with 3 portions. In order to solve for inequality with 3 portions, we try to get x by itself in the middle portion. what we can do here is I can subtract 2 from all 3 portions. On the left side, 4 minus 2 is 2. In the middle, 2 get cancelled, I get s by itself. On the right side, 10 minus 2 is a. Here I get s by itself in the middle portion. So that's a solution to this inequality. Next, how do we graph this solution? Let's draw a number line first. Number 2 is somewhere in the number line. Since 2 is not included, use an open circle for 2. And number a is greater than 2, so a is on the right side of 2. And since a is not included, use open circle for a. Here, x is between 2 and a, so share the region between 2 and a. Since x is between 2 and a, I share the region between 2 and a. That's a graph for this solution. Next, how can we run the answer using interval notation? Look at the graph here. For the shaded region, the left endpoint is 2. 2 is not included. Right endpoint is a. A is not included. That's the interval notation of the solution. Next, negative 10 is less or equal to x minus 3, less or equal to 2. Here I can add 3 to all 3 parts, and then I can get s by itself. Add 3 to all 3 parts. On the left side, negative 10 plus 3. When we're adding two numbers of different sign, keep the sign from the number that has larger magnitude. Since 10 has larger magnitude, I keep negative sign. And then subtract the magnitude. 10 minus 3 is 7. In the middle, I get s by itself. In the right side, 2 plus 3 is 5. Since I get s by itself in the middle, that's the solution for this inequality. And then next, let's graph the answer. Let's graph the solution. Negative 7 is somewhere in the number line. And since negative 7 is included, draw a solid circle for negative 7. Number 4 is greater than negative 7. So number 4 is in the right side of 7. Since 4 is included, draw a solid circle. Here, x is between negative 7 and 5. So straight the region between negative 7 and 5. Since x is between negative 7 and 5, straight the region between negative 7 and 5. That's the graph of this solution. Next, let's run the answer using interval notation. For interval notation, look at the shaded region here. For the shaded region here, left endpoint is negative 7 and it's included. Right endpoint is 5, it's also included. That's an answer in interval notation. Next, negative 4 is less than 2x, less or equal to 6. We try to get s by itself in the middle, so I can divide all 3 parts by 2. If I divide all 3 parts by 2, in the middle I get s by itself. In the left side, negative 4 divided by 2 is negative 2. In the right side, 6 divided by 2 is 3. Since I get s by itself in the middle, that's the final answer. Now, how do we graph the solution? Let's first of all draw a number line. Negative 2 is somewhere in the number line. Since negative 2 is not included, draw open circle. Number 3 is in the right side of negative 2, since number 3 is larger. And number 3 is included. We draw a solid circle for number 3. Since x is between negative 2 and 3, we show the region between negative 2 and 3. That's a graph for the answer. Next, how do we run the answer using interval notation? Look at the shaded region here. The left endpoint is negative 2, and negative 2 is not included. Right endpoint is number 3. 3 is included, so use angle bracket. That's an answer in interval notation. Next, Negative 18 is less than negative 3x, less or equal to negative 6. Negative 18 is less than negative 3x, less or equal to negative 6. So we try to get x by itself in the middle portion. Here I can divide all three parts by negative 3. Divide all three parts by negative 3. Be very, very careful. When we divide inequality by negative number, we must switch the direction of inequality sign. Be very, very careful. When we divide inequality by negative number, we must switch the direction of inequality sign. And then in the left side here, negative 18 divided by negative 3 is positive 6. In the middle, negative 3 can cancel, we get x by itself. In the right side, negative 6 divided by negative 3 is positive 2. And in general, for the final answer, we try to write a smaller number in the left side. For the final answer, we try to write a smaller number in the left side. 6 is greater than x is greater than 2. We try to put a smaller number in the left side. That's the same as saying 2 is less or equal to x less than 6. For the final answer, we try to put a smaller number in the left side. So 2 is less than x and less than 6. And then next, let's graph the solution. Draw number line first. Number 2 is somewhere in the number line, and 2 is included. Draw a solid circle. 6 is in the right side of number 2, since 6 is larger. 6 is not included, so we use open circle. Since x is between 2 and 6, share a region between 2 and 6. That's a graph of the solution. Next, let's write the answer in interval notation. For interval notation, first of all, look at the straight region here. For the straight region, left endpoint is 2. 2 is included. Right endpoint is 6. 6 is not included. That's an answer using interval notation. Next, 3 is less or equal to 4x minus 1 and less than 19. We try to get x by itself. That's the goal. Try to get x by itself in the middle. That's the goal. I can first of all add 1 to all three parts. Then I have 4 and 4x in the middle. 19 plus 1 is 20. Next, I can divide all three parts by 4. If I divide all three parts by 4, I get x by itself in the middle. In the right side, 4 divided by 4. In the left side, 4 divided by 4 is 1. In the right side, there's no equal sign. There's no equal sign below inequality. 20 divided by 4 is 5. So here, x is between 1 and 5, including 1, but not 5. That's a solution for this inequality. Next, let's graph this solution. Number 1 is somewhere in the number line, and number 1 is included. Draw a solid circle for number 1. Number 5 is in the right side of number 1, and 5 is not included. Draw open circle for number 5. Here x is between 1 and 5. So share the region between 1 and 5. That's a graph of the solution. Next, let's write the answer. Let's write the solution using interval notation. For interval notation, look at the graph here. Look at the straight region. For the straight region, the left endpoint is number 1. Number 1 is included. Right endpoint is number 5. 5 is not included. That's an answer using interval notation. Next, negative 23 is less or equal to 2 minus 5x, and it's less than 12. We try to get x by itself in the middle. So what we can do first is I can subtract 2 from all 3 parts. On the left side, negative 23 plus negative 2. When we're adding 2 numbers of the same sign, given the sign and the magnitude, 23 plus 2 is 25. In the middle, 2 get cancelled. You get negative 5x by itself. In the right side, 12 minus 2 is 10. Next, we try to get x by itself in the middle. So I divide all 3 parts by negative 5. Now be very, very careful. When we divide inequality by negative number, the direction of inequality sign change. In the left side here, negative 25 divided by negative 5 is number 5. In the middle, we get x by itself. In the right side, positive 10 divided by negative 5 is negative 2. Here, 5 is greater than negative 2. In general, for the answer, we write a smaller number first. In general, for the final answer, we write a smaller number first. So this answer can be rewritten as negative 2 is less than x, less or equal to number 5. That's the solution to this inequality. Next, let's graph the solution. Draw number line first. Negative 2 is somewhere in the number line. It's not included. Number 5 is larger than negative 2. It's somewhere here, somewhere in the number line. And 4 is greater than 2. 4 is greater than negative 2. Here 4 is included. Since x is between negative 2 and 5, we shade the region between negative 2 and 5. That's a graph of the solution here. Next, let's run the solution using interval notation. For interval notation, look at the shaded region here. Left endpoint is negative 2, and it's not included. Right endpoint is 5. 5 is included. That's an answer in interval notation. Next, let me introduce inequalities with absolute values. For absolute value, we know that absolute value of positive number stays the same. For absolute value of negative number, we drop negative sign, make it positive. Absolute value of positive number stays the same. For absolute value of negative number, drop negative sign, make it positive. So keep this idea in mind. For all real number x, absolute value of x is always greater than or equal to 0. It can never be negative. If x is positive, it stays the same. If x is negative, drop negative sign, make it positive. So absolute value of x can never be negative. It's always greater than or equal to 0. Next, let me introduce some rules for inequalities with absolute value. First rule, it says, if absolute value of x is less than a, where a is a positive number, then x is between negative a and positive a. Let me show you an example. For example, absolute value of x is less than 3. How do we get this answer? Let me show you a number line. First. In the number line, we have 0 in the middle. Numbers to the right side are positive. Numbers to the left side are negative. Now, let's test for absolute value of x. If I plug in 0, absolute value of 0 is 0, which is less than 3. So 0 is a good point. If I plug in 1, absolute value of 1 is 1. 1 is less than 3, so that's okay. If I plug in 2, absolute value of 2 is less than 3. That's good. How about 3? Absolute value of 3 is not less than 3. So 3 is not included. Draw open circle at 3. How about 4? Absolute value of 4 is larger than 3. So the rest cannot be included. On the other side, how about negative numbers? Absolute value of negative 1 is 1. 1 is less than 3. So that's okay. That's a good point. Absolute value of negative 2 is positive 2. 2 is also less than 3. So that's good. Absolute value of negative 3 is 3. 3 is not less than 3. So negative 3 cannot be included. Draw open circle here. It cannot be included. Absolute value of negative 4 is 4. 4 is larger than 3. So it cannot be included. So all we have is the number between negative 3 and 3. All these numbers are good. All these numbers satisfy this inequality. So that means all real number between negative 3 and 3. So that means x is between negative 3 and 3. That's why if absolute value of x is less than a, where if a is positive, then s is between negative a and a. Here 3 is negative, 3 is positive. So s is between negative 3 and 3. That's the first rule, keep it in mind. If absolute value of x is less than a, where a is positive, then x is between negative a and a. That's the first rule. Second rule. If absolute value of x is greater than a, where a is positive, then either x is less than negative a or x is greater than a. If absolute value of x is greater than a, where a is positive, then either x is less than negative a or x is greater than a. Let me show you an example. It will make more sense to you. Let's look at this. Absolute value of x is greater than 3. Absolute value of x is greater than 3. Let's draw the graph first. If we draw a number line, we can see that 0 is in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers to the right side go all the way to infinity. Numbers to the left side go all the way to negative infinity. Now let's test each number. Absolute value of 0 is 0. 0 is not greater than 3, so that's not a good point. That's a bad point. How about 1? Absolute value of 1 is not greater than 3, so that's not a good point. Absolute value of 2 is not greater than 3, so that's not a good point. Absolute value of 3 is not greater than 3, so this endpoint is not included. This endpoint is not included. Draw open circle here. How about 4? Absolute value of 4 is 4. 4 is greater than 3, so that's good. How about 5? Absolute value of 5 is greater than 3, so that's also good. All numbers here are good. All number here satisfies inequality. Now on the other side, let's test for negative number. Absolute value of negative 1 is 1. 1 is not greater than 3, so that's a bad point. Absolute value of negative 2 is 2. 2 is not greater than 3, so that's a bad point. Absolute value of negative 3 is 3. 3 is not greater than 3, so this point 3 is not included. Negative 3 is not included. If I plug in negative 4, absolute value of negative 4 is 4. 4 is greater than 3, so that's a good point. Absolute value of negative 5 is 5. It's positive 5. 5 is also greater than 3. So all numbers after negative 3, when I take absolute value, they're all greater than 3. So all these points satisfies this inequality. So here we have two pieces here. We have two regions. First region is from negative infinity to negative 3. Another region is from 3 to infinity. If there are two intervals, I can use union to combine them together. This region here is x less than negative 3. All numbers here are less than negative 3. This region here are x greater than 3. That's why it's like x is either less than negative a or x is greater than positive a. Either x is less than negative 3 or greater than 3. So that's the rule. If absolute value of x is greater than a, where a is positive number, then either x is less than negative a or x is greater than a. That's the second rule. Next, if absolute value of x is less than a, where a is negative, then what? If absolute value of x is less than a, where a is negative number, then what? We know that absolute value of x is always greater than or equal to 0, so it won't be negative. If it won't be negative, it won't be less than a negative number, so that's impossible. Absolute value of x, it won't be less than a negative number, that's impossible. Then there's no solution. That's impossible, there's no solution. There are no solutions for x. If there's no solution for the interval notation, we use this symbol. This symbol represents NP set. If there are no solutions for interval notation, we use this symbol. This symbol means there are no solutions. This symbol means it's an empty set. There are no solutions. That's case 3. If absolute value of x is less than a, where a is negative, then there are no solutions for x. That means absolute value of x cannot be less than a negative number. Next, if absolute value of x is greater than a, where a is negative, if absolute value of x is greater than a, where a is negative, then what? We know that absolute value of x is always greater than 0. Therefore, it's always greater than any negative number. Since this is a positive number, it's always greater than any negative number. Positive number is always greater than negative number. Then this is true for all x. Then the solution is all real numbers. This is true for all real numbers. Therefore, the solution is the set of all real numbers. The solution is the set of all real numbers. All real numbers means the entire number line. The entire number line from negative infinity to infinity. all real numbers means the entire number line from negative infinity to infinity. So if we try to answer using interval notation, left endpoint is negative infinity, right endpoint is infinity. The solution is always the set of all real numbers. If absolute value of x is greater than a, where a is a negative number, then the solution is always all real numbers. Inequality is always greater than a negative number. This is true for all real numbers. So the solution is a set of all real numbers. So keep these 4 rules in mind, especially the first 2 rules. Next, let's look at some examples. Solve each of the following inequalities. Graph the solution and write the answer in interval notation. First example, absolute value of x is less than 1. If absolute value of x is less than 1, then according to the first rule, we know that x is between -1 and 1. That's the solution to this inequality. And the graph looks like this. Let's draw a number line first. -1 is here, it's not included. +1 is here, it's not included. X is between -1 and 1. Share the region between -1 and 1. That's a graph to the solution. And then for interval notation, look at the shaded region here. Left endpoint is -1. Right endpoint is +1, and they are not included. That's the answer using interval notation. Next, absolute value of x is greater or equal to 4. Absolute value of x is greater or equal to 4. According to the second rule, if absolute value of x is greater than a positive number, then there are 2 cases. Either x is less than -4, or x is greater or equal to +4. By rule number 2, if absolute value of x is greater than a positive number, there are 2 cases. Either x is less than -4, or x is greater than 4. That's the answer, that's the solution to this inequality. Next, let's draw the graph. Let's graph the solution. -4 is somewhere in the number line, so it's here. Since it's included, draw a solid circle. +4 is greater than -4, so it's in the right side. Then, for x is less than -4, we share the region to the left of -4. For x is less than -4, share the region to the left of -4. For x is greater than 4, share the region to the right side of 4. Then we have 2 pieces here. For the shaded region, we have 2 pieces. That's a graph to the solution of this inequality. Next, for the interval notation. For the interval notation, look at the shaded region here. There are 2 pieces. For the first piece, left endpoint is negative infinity. Right endpoint is -4. -4 is included. For the second piece, left endpoint is 4. 4 is included. Right endpoint is infinity. Infinity is not included. And then if there are two intervals, we use interval in the middle to connect 2 intervals. We use union in the middle. This is called union. This symbol is called union. Put unions in the middle. Then connect 2 intervals together. Next, absolute value of x is less or equal to -2. Absolute value of x is less or equal to -2. We know that absolute value of x is always greater than or equal to 0. It won't be less than -2. So that's impossible. By rule number 3, if absolute value of x is less than a negative number, then there are no solutions. If there are no solutions, for the graph, we leave the number line blank. If there is no solution, for the graph, we leave the number line blank. If there are no solutions, we leave the number line blank. For interval notation, write empty set. This symbol represents empty set. That means there are no solution. This symbol means empty set. If there are no solution for interval notation, write empty set. Next, absolute value of x is greater than -6. We know that absolute value of x is always greater or equal to 0. It's always positive. Therefore, it's obviously greater than -6. So this is true for all real numbers. This is true for all real numbers. So this is true. The solution is all real numbers. The solution is all real numbers. How do we graph all real number? All real number means the entire number line. All real number means the entire number line. So for the graph, shade the entire number line. If the solution is the set of all real numbers, for the graph, we shade the entire number line. That's the graph of the solution. And then, for interval notation, look at the shaded region here. For the shaded region, left endpoint is -infinity. Right endpoint is positive infinity. So for interval notation, it's the interval from -infinity to infinity. That's the left endpoint. That's the right endpoint. Next, absolute value of x plus 1 is less than 5. Absolute value of x plus 1 is less than 5. Consider this is a number. So according to rule number 1, if absolute value is less than some positive number, then whatever inside is between -5 and +5. If absolute value is less than a positive number, then whatever inside is between -5 and +5. If absolute value is less than 5, whatever inside is between -5 and 5. That's rule number 1. And then we try to get s by itself in the middle. Here I can subtract 1 from all 3 parts. I get s in the middle. In the left side, -5 plus -1. When adding two numbers with the same sign, keep the sign add the magnitude, I get 6. For the number in the right side, 5 minus 1 is 4. So that's the solution to this inequality. And then for the graph, draw number line first. -6 is somewhere in the number line, and it's not included. Draw open circle. Number 4 is in the right side of -4. It's in the right side of -6, and it's not included. Draw open circle. It's not included. Since x is between -6 and 4, straighten the region between -6 and 4. That's the graph of the solution. And then, for interval notation, look at the shaded region. Left endpoint is -6. Right endpoint is 4. That's the interval notation. That's the solution. Interval notation of the solution. Next, absolute value of 3x minus 4 is less or equal to 10. Here, we have an absolute value less than 10, and 10 is positive. Then according to rule number 1, what's inside 3x minus 4 must be between -10 and 10. Then, in order to solve this inequality, we try to get s by itself in the middle. What we can do first is I can add 4 to all 3 parts. If I add 4 to all 3 parts in the left side, -10 plus 4 when we're adding two numbers with different sign, keep the sign from the number with larger magnitude. Here, negative 10 has larger magnitude, so keep negative sign. Then subtract the magnitude. 10 minus 4 is 6. In the middle, 4 can cancel, we got 3s by itself. In the right side, 10 plus 4 is 14. And then I can divide all three parts by 3. If I divide all three parts by 3, in the middle I get s by itself. In the left side, negative 6 divided by 3 is negative 2. In the right side, 14 divided by 3, that's not divisible, so leave it the way it is. Leave it as 14 over 3. That's the solution to this inequality. Next, let's graph the solution. Draw a number line first. Negative 2 is somewhere in the number line, and it's included. So draw a solid circle for negative 2. 14 over 3 is larger than negative 2, so it's in the right side. Also, it's included, so draw a solid point. Draw a solid point for 14 over 3. Since x is between negative 2 and 14 over 3, share the region between negative 2 and 14 over 3. That's a graph to the solution. That's a graph of the solution. Next, let's write the solution using interval notation. For interval notation, look at the shaded region here. Left endpoint is negative 2 and it's included. Right endpoint is 14 over 3. It's also included. That's the interval notation of the solution. That's the solution in interval notation. Next, absolute value of 1 minus 2x is less or equal to 7. Here we have absolute value less than 7. 7 is a positive number. Then by rule number 1, what's inside? It's between negative 7 and positive 7. We try to get x by itself in the middle. So what we can do first is I can subtract 1 from all three parts. In the left side, negative 7 plus negative 1 is negative 8. In the middle, positive 1 and negative 1 can cancel, we get negative 2x by itself. In the right side, 7 minus 1 is 6. Next, I can divide all three parts by 2, by negative 2. For inequality, if I divide inequality by negative number, the direction of inequality sign must be changed. When we divide inequality by negative number, the direction of inequality symbol must be switched. Here in the left side, negative 8 divided by negative 2 is positive 4. In the middle, negative 2 will cancel, we get s by itself. In the right side, 6 divided by negative 2 is negative 3. So we have 4 is greater or equal to x, and x is greater or equal to negative 3. Since 4 is larger than 3, in general, we prefer to write smaller number in the left side. So this can be rewritten as negative 3 is less or equal to x, less or equal to 4. That's the solution to this inequality. Next, let's graph the solution. Negative 3 is somewhere in the number line, and it's included. 4 is larger than negative 3, so it's in the right side of negative 3. It's also included. Since x is between negative 3 and 4, share a region between negative 3 and 4. That's the graph of the solution. Next, let's write the solution using interval notation. For interval notation, look at the shaded region. For the shaded region, you can see that the left endpoint is negative 3. It's included. Right endpoint is positive 4. It's also included. That's an answer using interval notation. Next, absolute value of x minus 6 is greater than or equal to 4. Absolute value of x minus 6 is greater or equal to 4. Here 4 is positive. According to rule number 2, if absolute value is larger than a positive number, then what's inside? What's inside is either less or equal to negative 4 or greater than 4. If absolute value is greater than a positive number, then the inside is either less than negative 4 or greater than positive 4. And there are two cases. We must solve both inequalities. Let's solve for the first one. For the first inequality, I can add 6 to both sides. That means x is less or equal to negative 4 plus 6 is positive 2. The other one, I can add 6 to both sides. I get s is greater or equal to 10. So for the solution, x is either less or equal to 2 or greater or equal to 10. That's the answer. That's the solution to this inequality. Next, let's graph the solution. Draw number line first. Number 2 is somewhere in the number line. And number 2 is included. Draw solid point. 10 is larger than 2. So 10 is in the right side of 2. 10 is larger than 2. So 10 is in the right side of 2. First inequality says x is less than 2, less or equal to 2. The region to the left of 2 is less or equal to 2. So share the region here. Share the region to the left of 2. Second inequality says x is greater than or equal to 10. The number to the right side of 10 is greater than 10. So share the region to the right side of 10. That's a graph of this solution. That's a graph of the solution. Next, let's run the solution using interval notation. Let's look at the straight region here. There are two regions. For the first region, left endpoint is negative infinity. Right endpoint is 2. 2 is included. For the second region here, left endpoint is 10. 10 is included. Right endpoint is infinity. If there are multiple intervals, put union in the middle. If there are multiple intervals, put union in the middle. That's the solution using interval notation. Next, we have absolute value of yx plus 2 is greater than 13. Here we have absolute value greater than 13, and 13 is a positive number. According to rule number 2, what's inside? 4x plus 2 is either less than negative 13 or it's greater than positive 13. Let's do number 2. If our absolute value is greater than a positive number, then what's inside? It's either less than negative 13 or greater than positive 13. And then get x by itself. Solve for x. For the first inequality, I can first subtract both sides by 2. Then I have 5x less than 15. 4x less than negative 15. Then I can divide both sides by 5. Here x is less than negative 3. For the other inequality, I can subtract 2 from both sides. I get 5x is greater than 11. And then I can divide both sides by 5. Here I get x is greater than 11 over 5. 11 over 5 is not divisible, so we leave it the way it is. So the solution is either x less than negative 13 or x is greater than 11 over 5. Next, let's graph the solution. In the number line, negative 3 is somewhere here. It's not included. Draw open circle for negative 3. 11 over 5 is positive. That's greater than negative 3. So it's in the right side. It's not included. Draw open circle. And then for the first inequality, x is less than negative 3. Number to the left side of negative 3 is less than negative 3. So show the region to the left side of negative 3. Second inequality says x is greater than 11 over 5. Number to the right side are greater than 11 over 5. So show the region to the right. That's a graph of the solution. Next, let's write the solution using interval notation. For interval notation, let's look at the shaded region here. We have two shaded regions. For the first region, left endpoint is negative infinity. Right endpoint is negative 3. For the second region, left endpoint is 11 over 5. Right endpoint is infinity. If there are two intervals, use union in the middle. Write union in the middle. If there are two intervals, write union in the middle. Next, absolute value of 4x minus absolute value of 4 minus 3x is greater than or equal to a. Here we have absolute value is greater than a, and a is positive. According to rule number 2, if absolute value is greater than a positive number, then what's inside is either less than negative a or greater than positive a. That's rule number 2. Then solve both inequality for x. Let me solve the first inequality first. For the first inequality, I can first subtract 4 from both sides. That means negative 3x is less or equal to negative 12. And then I can divide both sides by negative 3. Be very, very careful. If I divide inequality by negative number, the direction of inequality must be switched. If I divide inequality by negative number, the direction of inequality must be switched. So here x is greater or equal to negative 12 divided by negative 3. Double negative is positive. 12 divided by 3 is 4. For the second inequality, do the same thing. Try to get x by itself. I can first subtract 4 from both sides. Again, negative 3x is greater or equal to 4. And then I can divide both sides by negative 3. So be very, very careful. When we divide inequality by negative number, the direction of inequality must be switched. And then in the left side, I get x by itself. In the right side, positive 4 divided by negative 3. The answer is negative. 4 over 3 is not divisible. I leave it the way it is. So x is less or equal to negative 4 over 3. That's the solution to this inequality. That's the solution. Next, let's graph the solution. Draw number line first. Number line is from negative infinity to infinity. Here we have two numbers, 4 and negative 4 over 3. Negative 4 over 3 is smaller, so it's in the left side. Negative 4 over 3 is smaller, 4 is larger. So negative 4 over 3 is in the left side. 4 is larger, it's in the right side. They are both included, so draw a solid circle. Now, first inequality says x is greater than or equal to 4. If x is greater or equal to 4, we show the region to the right side of 4. If x is greater or equal to 4, show the region to the right side of 4. The other one, x is less or equal to negative 4 over 3. If x is less than negative 4 over 3, show the region to the left side of negative 4 over 3. That's the graph of the solution. Next, let's write the solution using interval notation. For interval notation, look at the graph here. Look at the shaded region. There are two regions. In the first region, the left endpoint is negative infinity. Lower endpoint is negative 4 over 3. And it's included. For the second region, left endpoint is 4. It's included. Right endpoint is infinity. If there are more than one intervals, put union in the middle. If there are more than one intervals, put union in the middle. That's an answer using interval notation. Next, absolute value of x plus 6 is less than 15. In this inequality, we try to isolate absolute value of x first. So I can subtract 6 from both sides. I get absolute value of x is less than 9. If absolute value of x is less than 9, and 9 is a positive number, according to rule number 1, what's inside? X is between negative 9 and positive 9. By rule number 1, if absolute value of x is less than 9, x is between negative 9 and 9. That's the answer to this inequality. Then let's graph an answer. Negative 9 is somewhere here. Positive 9 is greater than negative 9, so it's in the right side. Since x is between negative 9 and 9, straight the region between negative 9 and 9. That's the graph of the solution. Next, let's write the solution using interval notation. Look at the shaded region here. For the shaded region here, left endpoint is negative 9. It's not included. Right endpoint is positive 9. It's not included. That's the solution in interval notation. That's the solution in interval notation. Next, absolute value of x minus 10 is greater or equal to negative 4. Absolute value of x minus 10 is greater than or equal to negative 4. Let's solve for absolute value of x first. Let's solve for absolute value of x first. Here I can add 10 to both sides. If I add 10 to both sides, absolute value of x is greater or equal to negative 4 plus 10. Well, we're adding two numbers with different sign. Keep the sign from the number with larger magnitude. Here, positive 10 has larger magnitude. Keep positive sign. And then subtract the magnitude. 10 minus 4 is 6. So absolute value of x is greater or equal to 6. Here, 6 is positive. By rule number 2, if absolute value of x is greater than a positive number, then what's inside is either less or equal to negative 6 or greater or equal to positive 6. That's the solution to this inequality. Next, let's graph the solution. Draw a number line first. Negative 6 is somewhere in the number line here. It's included, so draw a solid point. Positive 6 is larger than negative 6, so it's in the right side. That's positive 6. Look at the first inequality. X is less than negative 6. Region to the left side of negative 6 is less than negative 6. So let's draw this region here. Second inequality says x is greater than or equal to 6. Number to the right side of 6 is greater than 6. So show the region to the right side of 6. That's the graph of the solution. Next, let's write the answer using interval notation. Look at the shaded region here. There are two intervals here. There are two regions. For the first region, left endpoint is from negative infinity to negative 6, including negative 6. Second interval is from 6 to infinity, including 6. If there are two intervals, put union in the middle. If there are two intervals, put union in the middle. That's the solution using interval notation. Next, 2 times absolute value of x is less or equal to a. Here I can divide both sides by 2. I try to isolate absolute value first. So I can divide both sides by 2 here. If I divide both sides by 2, I get absolute value of x is less or equal to 4. Since absolute value of x is less or equal to 4, and 4 is positive, by rule number 1, what's inside is between -4 and +4. That's the solution to this inequality. Next, let's graph the solution. X is between -4 and 4. -4 is somewhere in the number line here. It's included, so draw starting point. 4 is larger than -4. So it's somewhere in the right side of -4. Since x is between -4 and 4, we show the region between -4 and 4 here. That's a graph to the solution. Next, let's write the answer in interval notation. In the graph, look at the straight region here. In the straight region, the left endpoint is -4, right endpoint is +4, and they are both included. That's the solution. That's the solution in interval notation. Next, -3 times absolute value of x is less than -6. So for inequality involve absolute value, we try to isolate absolute value first. For inequality contains absolute value, we try to isolate absolute value first. So here I can divide both sides by -3. When we divide inequality by negative number, always switch the direction of inequality sign. When we divide inequality by negative number, always switch the direction of inequality sign. So in the left side, -3 get cancelled. We get absolute value of x by itself. In the right side, -6 divided by -3, double negative is positive. 6 divided by 3 is 2. So here we have absolute value of x is greater than 2. 2 is a positive number. By rule number 1, by rule number 2, if absolute value of x is greater than a positive number, then what's inside is either less than -2 or greater than +2. That's rule number 2. It says, if absolute value of a number is greater than a positive number, then what's inside is either less than the negative value of this number or greater than the positive value of this number. That's rule number 2. And that's the solution to this inequality. Next, let's graph the solution. First of all, put these two numbers in the number line first. Put -2 and +2 in the number line first. -2 is smaller, so it's in the left. +2 is larger, it's in the right. They are not included, so draw open circle for these two numbers. First inequality says x is less than -2. We know that number to the left side of -2 is less than -2. So we'll show the region to the left side of -2. The other inequality says x is greater than 2. We know that the number to the right side of 2 is greater than 2. So show the region to the right side of 2. That's a graph of the solution. Next, let's write a solution using interval notation. In the graph, look at the straight region here. There are two regions. In the first region, left endpoint is from -infinity to -2. That's left endpoint, that's right endpoint. For the other region, left endpoint is 2. Right endpoint is infinity. If there are multiple intervals, put union in the middle. That's a solution in interval notation. Next, 3 times absolute value of x minus 4 is less than 20. In an inequality, if it contains absolute value, let's isolate absolute value first. I can first of all add 4 to both sides. I get 3 times absolute value of x is less than 24. And then I can divide both sides by 3. I get absolute value of x is less than a. Here, absolute value of x is less than a, and a is a positive number. By rule number 1, what's inside is between negative a and positive a. That's rule number 1. And then, graph the answer. Let's first of all put negative a and a in the number line. Negative a is smaller, a is larger. And they are both not included, so draw open circle for both numbers. Here, x is between negative a and a. X is between negative a and a. So it's just a region between these two numbers. That's a graph of the solution. Next, let's write the answer using interval notation. Look at the straight region in the graph. Left endpoint is negative a. Right endpoint is positive a. And they are not included. That's an answer in interval notation. Next, phi minus absolute value of x is greater or equal to 3. In inequality, if we contain absolute value, let's isolate the absolute value first. Here I can subtract phi from both sides. I get negative absolute value of x is greater or equal to 3 plus negative phi. When adding two numbers with different sign, keep the sign from the number that has larger magnitude. Here negative phi has larger magnitude, so keep negative sign, and then subtract the magnitude. Phi minus 3 is 2. Here we have negative absolute value of x is greater or equal to negative 2. So in order to isolate absolute value of x, I can consider this as negative 1 times absolute value of x. I can consider negative absolute value of x as negative 1 times absolute value of x. Then I can divide both sides by negative 1. I get absolute value of x in the left side. Negative 2 divided by negative 1 is positive 2. Now be very, very careful. When we divide inequality by negative number, the direction of inequality sign will be switched. When we divide inequality by negative number, the direction of inequality sign will be switched. Greater than or equal to become less than or equal to. Here we have absolute value of x is less or equal to 2, and 2 is a positive number. By rule number 1, what's inside is between negative 2 and 2. That's rule number 1. That's a solution to this inequality. That's a solution to this inequality. Next, let's graph the solution. First of all, put negative 2 and 2 in the number line. Negative 2 is smaller, it's in the left side. 2 is larger, it's in the right side. And they are both included, so draw solid point for both of them. Since x is between negative 2 and 2, so it's just a region between negative 2 and 2. Share a region between negative 2 and 2. That's a graph of the solution. And then, for the answer in interval notation, look at the straight region here. Left endpoint is negative 2. Right endpoint is positive 2. And they are both included. That's a solution in interval notation. Next, absolute value of 2x plus 9 plus 6 is less than 17. In inequality, if it contains absolute value, let's isolate absolute value first. I can first of all subtract 6 from both sides. So I get absolute value of 2x plus 9 is less than 11. And then, since this absolute value is less than 11, and 11 is a positive number, by rule number 1, what's inside is between negative 11 and positive 11. Then we try to get x by itself in the middle. I can first of all subtract 9 from all three parts. in the left side, negative 11 plus negative 9. When adding two numbers with the same sign, keep the sign, add the magnitude, I get negative 20. In the middle, I get 2x. In the right side, 11 minus 9 is 2. Next, I can divide all three parts by 2. In the left side, negative 20 divided by 2 is negative 10. In the middle, 2x divided by 2 is x. In the right side, 2 divided by 2 is 1. That's the solution to this inequality. Next, let's graph the answer. Let's graph the solution. First of all, let's put negative 10 and 1 in the number line. They are not included. So use open circle. Negative 10 is smaller, 1 is larger. Since x is between negative 10 and 1, we share the region between these two numbers. That's the graph of the solution. Next, let's run the solution using interval notation. Look at the straight region here. Left endpoint is negative 10, it's not included. Right endpoint is 1, it's also not included. That's the interval notation of the solution. Next, absolute value of 3x minus 5 minus 2 is greater or equal to 18. In an inequality, if it involves absolute value, let's isolate absolute value first. I can first add 2 to both sides. Let's isolate absolute value first. Add 2 to both sides. I get absolute value of 3x minus 5 is greater or equal to 20. Then, if absolute value is greater than 20, and 20 is a positive number, by rule number 2, what's inside is either less or equal to negative 20 or greater than positive 20. Then, in both inequality, try to look at x by itself. In the first inequality, I can add 4 to both sides. If I add 4 to both sides, I get 3x is less or equal to negative 15. Negative 20 plus 5. We're adding two numbers of different sign. Keep the sign for a number that has larger magnitude. Negative 20 has larger magnitude, so keep negative sign. And then subtract the magnitude. 20 minus 5 is 15. Next, I can divide both sides by 3. If I divide both sides by 3, I get x is less or equal to negative 5. That's the solution to the first inequality. Now solve the second one. Do the same thing. Get x by itself. I can first go f1 to both sides. I get 3x is greater or equal to 25. And then divide both sides by 3. If I divide both sides by 3, I get x is greater or equal to 25 over 3. 25 divided by 3 is not divisible. I leave it the way it is. So that's the solution to this inequality. Next, let's graph the solution. First of all, let's put these two numbers in the number line. Negative 4 is smaller, it's in the left side. 25 over 3 is larger, it's in the right side. They are both included, so draw a solid circle for both of them. Now, first inequality, x is less or equal to negative 5. The region to the left of negative 5 is less than negative 5. So let's show the region to the left. Second inequality, x is greater than or equal to 25 over 3. Region to the right side is greater than, region to the right side of 25 over 3 is larger than 25 over 3. It should be 25 over 3. Then show the region to the right side of 25 over 3. That's the graph of the solution. Next, let's run the solution in interval notation. For solution in interval notation, let's look at the graph first. In the graph, there are two straight regions. Here. For the first straight region, left endpoint is negative infinity. Right endpoint is negative 5. Negative 5 is included. For the second straight region, left endpoint is 25 over 3. lower endpoint is infinity. 25 over 3 is included. If the answer contains more than one intervals, we must use union in the middle. Put union in the middle. That's the answer in interval notation. Next, 5 times absolute value of 2x minus 1 minus 4 greater than 11. So in inequality, if we contain absolute value, let's isolate absolute value first. So I can first of all add 4 to both sides. In the left side, I get 5 times absolute value of 2x minus 1 greater than 11 plus 4 is 15. Next, I can divide both sides by 5. If I divide both sides by 5, in the left side, I get absolute value of 2x minus 1 by itself. In the right side, 15 divided by 5 is 3. Now here we have absolute value is greater than 3, and 3 is positive. Since absolute value is greater than positive number, by rule number 2, what's inside? It's either less than 3, less than negative 3, or greater than positive 3. By rule number 2, what's inside? 2x minus 1 is either less than negative 3 or greater than positive 3. Then solve both inequality individually. For the first inequality, I can add 1 to both sides. I get 2x is less than negative 3 plus 1. When adding two numbers with different sign, keep the sign from the number that has larger magnitude, and then subtract the magnitude. 3 minus 1 is 2. Next, I can divide both sides by 2. I get x is less than negative 1. Now let's solve the other inequality. For the other inequality, I can add 1 to both sides. I get 2x is greater than 4. 3 plus 1 is 4. Next, I can divide both sides by 2. If I divide both sides by 2, I get s is greater than 2. That's the solution to this inequality. Next, let's graph the solution. First of all, put these two numbers, negative 1 and 2, in the number line. Negative 1 is smaller, 2 is larger, so put negative 1 in the left, 2 in the right. And they are both not included, so draw open circle for both of them. First inequality says x is less than negative 1. Number to the left side of negative 1 is less than negative 1. So share the region to the left side of negative 1. Second inequality says x is greater than 2. Number to the right side of 2 is greater than 2. So let's share the region to the right side of 2. That's the graph of the solution. Next, let's write the solution using interval notation. For interval notation, look at the graph here. There are two shaded regions. For the first shaded region, left endpoint is negative infinity, right endpoint is negative 1, and negative 1 is not included. For the second shaded region here, left endpoint is 2. 2 is not included. Right endpoint is infinity. If there are more than one intervals, we must put union in the middle. That's an answer in interval notation. Next, 6 minus 3 times absolute value of 4x plus 6 less or equal to negative 12. 6 minus 3 times 4 times 6 minus 3 times absolute value of 4x plus 6 less or equal to negative 12. In an inequality, if it contains absolute value, we will need to isolate absolute value first. So here I can subtract 6 from both sides. I get negative 3 times absolute value of 4x plus 6 less or equal to negative 12 plus negative 6. When we are adding two numbers of the same sign, keep the sign and the magnitude. 12 plus 6 is 18. Next, I can divide both sides by negative 3. Here in the left side, I get absolute value by itself. Negative 3 get cancelled. We get absolute value of 4x plus 6 by itself. In the right side, negative 18 divided by negative 3. If two numbers have the same sign, type of negative is positive. 18 divided by 3 is 6. Here we get absolute value of 4x plus 6 is less or equal to 6. 6 is positive. 6 is positive. So by rule number 1, if absolute value is less than a positive number, then what's inside is between negative 6 and positive 6. Next, we try to get x by itself in the middle. I can first of all subtract 6 from all three parts. In the left side, negative 6 plus negative 6 is negative 12. In the middle, we get 4x by itself. In the right side, 6 minus 6 is 0. Next, I can divide all three parts by 4. I get negative 3 is less than or equal to x, less or equal to 0. That's a solution to this inequality. Next, let's graph the solution. Let's first of all put negative 3 and 0 in the number line first. Let's put negative 3 and 0 in the number line. Negative 3 is smaller. 0 is larger. They are both included, so draw starting point. They are both included, so draw starting points. Here, x is between negative 3 and 0. So shade the region between negative 3 and 0. Here, x is between negative 3 and 0. So shade the region for both. Shade the region between these 2 points. That's a graph to this solution. That's a graph of the solution. Next, let's find the answer using interval notation. For interval notation, in the graph, let's look at the shaded region. In the shaded region here, left endpoint is negative 3. It's included. Right endpoint is 0. It's also included. That's a solution in interval notation.